Putting cartridges together is not that difficult, but to put a good cartridge together takes time. It has taken me 43 years and about 2,000 hours per year in building and in repairing. So that's about 80,000 hours of work. And then everything looks easy. But there are two subjects. It's the mechanical section and it's the audio section. So mechanical, everything can be looking fine, but still it should sound good. And that's the next step. So the first step is how to put something together that it works, like a watchmaker. The thing is moving and ticking, but to have the right time with something else. Yeah. I think I'm trained to produce also the right time and not just that the clock works. And it's lucky enough recognized by a lot of reviews in your country already and still coming. So I'm happy that this all together works well. Today I'll put a Grimson together. It's a cartridge based on a body made of koa wood. This is the stem I used before the branches. This is a little bit harder wood. And it's pure, it's not coated, so it's just the material as it comes from the tree. I'll give a little bit more light. It's about not to be overexposed. Yeah. And what I'm doing today is just fiddling all parts together. I will give explanation why I'm doing things and how I'm doing things, but you can see yourself also. So after careful observation, you can put the cartridge together. How it will sound is another story, and that's more or less up to you to take a decision. So far, any question what I should specifically pay attention to? Any specific question? No? A cartridge is about 7-8 grams. So you put a lot of things together and the final weight is 7-8 grams. Coil wire is 20 micron. And you will see I will twist coil wires, and when you are not trained to do that, you spoil coil after coil after coil, and you get hopeless. So be relaxed, no trouble in the family, pay your taxes, pay your bank, have no trouble with the neighbors, celebrate your mother-in-law, because that's an essential part in a male life. When that all is done well, maybe you can make a start. But the most important thing is have extremely stable hands, very well controlled movements. So no alcohol, not heavy exercises. When I come from Europe and carry luggage, I cannot make a cartridge in 24 hours. That's an impossibility. So I have to wait for more than 24 hours. When I come home again, it also takes more than 24 hours before I have control over my hands. Of course, I can make a cup of coffee. And I can write something, but these fine movements take really time. So sleep well, no alcohol, no trouble in the family, and you can become a cartridge maker. In the past, during the high time of CD, people said I was crazy because there was no money and everything should be digital. And I said, no, I trust my ears. I believe alcohol is not the right way, but analog is the better way. So I continue to work on cartridge improvement, and today is high time again for phono. I think analog will continue with LP and tape, and digital will continue with streaming. CD may die out after a while, but all is on an extremely low level available. So streaming or LP and tape. If you keep that in mind, then this might be an interesting morning. Good, I'll make a start. First is the connector, and before you can connect anything in electronics, you have to wetten it with solder. I have no idea about the temperature of this soldering station, but I think it's about right. I took a tin, 95% tin and 5% silver, to avoid also dissolving the connecting wire. So the first thing that I'm doing is now, this is the first try with the soldering device, but it works well. Yeah. Adding some solder at the pins. should be short, otherwise the pin gets too hot and melts. So that's one. Put it aside. Then I take the 4 lead wires that should be connected to the 4 pins. I use this moldable material because this is very easy to fix everything. I have 4 different colored wires. I put them in the correct order with my tweezers. Red first, green, the insulation of this wire takes about 425 degrees. I'm talking in Celsius and not in Fahrenheit. Otherwise, I keep always a strict order to avoid any mistakes. The good message is that my son William is also very interested in building cartridges. So there's hope for those who told me before what will happen after I died, what I think is a very positive feeling. So, soldering the ends. I have to move a little bit. At home I do this automatically, but this is a little bit different situation, so sometimes I have to adjust here. The good thing for me is that cartridge building is a complete automated process, so I have plenty of time to think. Start with red. I put my finger, this is called the finger thing, always on the red one. And then turn me a little bit down in temperature. Because the solder burns. It's not the finest tip you can think about, so I have to work with something. That's done. Temperature is a little bit too high. It should be a smooth soldering. It's not perfect. This is just a little bit of start when it works well. Yeah, this is going better. No, it could be better. I use an ultra fine tip, and this is a very coarse one. So the cosmetics are not super. It's connected, but not really a cosmetic interesting way. The body is here. So I adhesive the connector now in the body, but first I check the fitting. And it fits. Now, the glue. I always use 401. That's a famous one, Loctite 401. First I open it, then I squeeze the air out, add the adhesive at the rear. It penetrates the wood, so you have to add a second layer and press the connector inside. Hang on. It's still a jet lag. It fits. Gives a little extra adhesive. To keep it tight in position. Most of the adhesive disappears in the wood. So. That's one part. Close the adhesive. find a square with a hole in the middle. It's all together. That's this unit. This unit will be a contact area between the wood and the magnetic circuit. Separate the wires first. Not adhesive the wires. My son likes to put this cartridge specifically very much, so anyone who likes to buy in the future this model, you see the adhesive is disappearing in the wood again because it's very fiber-rich wood. So whatever you put over there, it disappears. Already all adhesive disappeared. This needs to be done very precise, centering. Anything but offset is later a problem. So I add adhesive also through the hole in the center, and then the adhesive is completely. This is not cosmetically the most perfect one I make, a little bit depending on situations, but it definitely will make sound. The next step is the magnetic circuit. That is a little bit precise work, so we keep this here drying. The magnetic circuit is the rear pole, a little bit some other parts, and the round one. So this is part of the magnetic circuit. The rear pole is a round edge and a square one. This is the one I like to use. A ring. A ring is called washer in English, isn't it? Yes, here we are. Now a little screw. The trick is to get this screw rotating without losing it. So I always put the tweezer in the hole. And once it picks up, then you can rotate. Questioning of tightening, but not completely, otherwise it can't rotate anymore for adjustments. I can't adjust here because I don't have the measurement equipment I have at home. Well, this is a part of the magnetic circuit. I put a little bit of adhesive at the rear to fix, but still it should be able to rotate. But this adhesive is enough. The next step is the magnet. I have a box with magnet somewhere. This was the measurement. Let's see. This. Magnets have an orientation. You may say, I put the magnet and it will work, but to have all cartridges with the same face in output, you have to check what's north and what is south. So therefore I need this compass and I'm looking for the north side. As you see it rotates, so I feel the south, and automatically this is north, and I need a north side. So I know plus is plus and minus is minus. I have a line on the magnet, so it's in the magnetic direction, because I can put it also in a 90-degree position. Take the powder, magnetic powder away, so we have perfect contact. Now it fits here. This is a matter of very precise adjusting. By the way, when the cartridge is ready, it is for sale. I use always the money to help group of children in Brazil. They were picked from the street, were using drugs, and I saved their life by putting them together in a group, and that's where the cartridge money is going. So, I'll do my best to outline it as good as I can, but you have the right to return to our importer, and I'll get it and fine-tune at home. This is really very precise work, because when this is done well, the cartridge is good. Looks good symmetric. So this is the magnetic circuit. Magnet, north at the rear, and precisely centered. This is what I adhesive on the body. Again, the adhesive disappears completely. Now you know why you can't put lacquer on it, because it disappears. When I talk, the lacquer is finished again, inclusive the adhesive. So you have to saturate and then fit this. This is essential. When this is done well, look at the front, look at top. It's okay. You see, it's very easy. Give some extra pressure. It starts to look like a cartridge. When I rotate, you can already recognize somewhat how the final version will be. Because of the high temperature of the soldering, the pins are not completely parallel, so I have to adjust this. Temperature I use is very precise, 425, and then everything works fine. But there's no temperature control in this soldering station. So, I don't need any corrections, all is okay. Maybe a little shift of the magnet. Adhesive is still flexible, so I can move and give some extra at front. Excellent. Next step is the printed circuit boards on the side. You need to in this box. That's the reason why. Two. I round the top corner a bit. That's for cosmetic reasons and also for easy mounting. So at the moment I'm shaping the little PC board. Can do by grinding, but then the fibers are really harmful when you inhale them, so always use mechanical cutting and never grinding. It shows up in a measurement as asbestos, but it is glass fiber. If there's too much in your lungs, you develop funny diseases. In our phono stage we use aerospace PC board that doesn't have any fibers, but it's too expensive to be used for a phono cartridge. Last cut. Ready. Hopefully this is more or less fixed. First thing what I do is rotate the 4 wires. Must be careful. No. First thing what I do is rotate the fibers, the wires. There's more than one reason. First, to make them straight. Second, it acts a little bit as an RF filter. Still need to press a little bit the magnet, yes. When I have not made a cartridge in a week time, it's a complete new learning again. So it's something you have to do day after day. So nicely turned. Turned. And done. Magnet is moving still a little bit. You have to reposition again. Ready. Now I need my tweezers to give the 4 lead out wires the correct position. Good tweezers are essential. I use mostly those of Dumont. It's a Swiss company, but when you want to buy them, you have to order in the States. Very strange. Any questions so far? It's so silent. The good thing is when you make cartridges, you can think and talk. Same what ladies do when they cook. When you come home, there's a lot of talk in the kitchen. To make it easy, I cut the top end to give a smooth passing. Now, next step is take the PC, red under, green above. Sometimes they don't like, but they have to. So this is the right channel. Put the adhesive. And position. Wait for a short while and squeeze with your hand and straighten the wire and position. Then I have to wait for a short while to press and the PC board is fixed. Check if no wire is under. Yes, red is under. So I have to save. Now it's okay. You see, it's not an automated process. It's, every time you have to take decisions. Is it okay? Isn't it okay? So this is it. Take the other channel. Have to cut. White should be under and blue up. You see, it's serious work, and There are some customers who think they can modify a cartridge by, for instance, putting silicone grease in the gap. And it sounds much better. And that's a big mistake, because the silicone grease is absorbed by the damping rubber, and after a while it doesn't damp anymore. So the cartridge doesn't track or becomes very aggressive. And when the owner finds out that he has done something, then he becomes aggressive to me. That's transfer of the problem. So you have to be polite and explain, tell him don't do again. I told last time, and I retell again, there was a story once that I got a cartridge from a Canadian owner, and he complained that, or he told me that I had horses. But I don't have horses because I don't have the time. I make cartridges. And his story was I had horses because he had to remove 4 horse hairs from the cartridge. But it was not a horse hair, it was his coil wire. So we removed his coil wire, and then he complained that I had horses and that the cartridge did hum. That's reality. So you have to educate, to explain, to be patient. Some cartridges sound aggressive, but it's not an aggressive cartridge, it's the cheap tone-down wire what makes it aggressive. So I have to tune the cartridge that the tone-down wire is compensated by a dull cartridge, but then the sound is not good anymore. But the cartridge is for many people a kind of tone control. And that's not honest. The defect is somewhere else. I cut the 4 wires, so there's just enough left to be connected to the golden mounting holes on the side of the PC board. Hopefully temperature is okay. The tip is magnetic. And there's another minor problem. The tip is too thick, so I can solder only on one end. It might be a problem in connecting the coil. Because I can't get between the magnet and the PC board. This is a tip more or less used for amplifier manufacturing and not for cartridge mounting. So I have to be a little bit improvising. Testing. Testing. But I can't get as easy on the bottom side. Oh, that will be complicated. I hope I can. I move the PC board a little bit away from the magnet. I'll fix later again. I hope I can. Good. Here's the cartridge. Anyone who likes to check? I have now to make the coil. And the coil is in the grey box, is here. This is more specialist work. I have here some coils. I'll take one of them. So this is one coil, as you can see. Flip it with the finger. Now I have to twist the leads. Can you see the single wire on the screen?
Yes.
Yeah, magnification is about, well, what should it be? Maybe 50. So you take 2 tweezers, clean them first, otherwise you stick with adhesive, or the risk of adhesive, to a single wire and it will break. And I'll twist the wires, but first I make a little bit of step-in magnification. And focusing. I have a size microscope, but that is in one step, but here you have to do it in double steps. It's about 20 turns I make. Again, my hands are still not stable after the trip, so it may look shaky, but I will not break them. Can you see on the screen what I'm doing? And I'm lucky here, the wires are more or less straight. Sometimes they're curved, and you have to find each wire.
What's the insulation on this wire?
It's a nylon of 0.5 micron.
Wow.
Now, the wire itself is 20 micron, and a human hair is 80. So it's a quarter of a human hair.
Who's able to make this wire? Not too many people, right? Or you have to pull it yourself through a die?
No, I bought it. I bought it in Switzerland from a factory that makes the wires for watches, electronic watches. And normally they use copper. You see, my hands are not really stable, so I apologize for a little bit shaky. This is about the right length. Straighten it. And that's it. Now take the other 2. This is a 2-layer coil. With the colibri you take a 6-layer coil. But the output of a crimson gets too high as if it's when I use a 6-layer. That's the reason why you shouldn't drink any alcohol or use drugs or whatever. Otherwise, it's a lost operation. This is okay. Separate the 2. Clean. Done. Now I'll turn these 2 groups around the coil. Yeah. Maybe magnification. I'll leave it. Let me see. I have a little bit of. I need a pin. I had a pin here. Otherwise, I use solid. I have to add a little bit of adhesive on the coil to fix the wires on the coil. So, the coil is embedded now with adhesive. Take 1 group, pass over the coil, turn around, go to the rear, and stretch. No, doesn't like a Sunday today. Here we are. The forces you can apply are minimum. it's over 50 milligram, or it's 1/20th of a gram, then that's it. So you must have extremely well controlled forces. No brute forces, no air force, nothing. In Europe, by the way, your president's airplane is called the Air Force One. So, this is done.
Hard to see in the picture now. What is that wound on? What's that core-looking piece in the?
There's a square, and the coils are wound around the square. One turn up, one turn down, comes out, and the input is also on the same end. I've twisted them.
What's that piece that, you know, looks like a tube in there like that?
You can point out with your finger.
You know, right?
Huh?
I don't know. What you wound the wire on this? You said it's square? You know, it's hard to tell.
You can see it cross.
Yes, cross.
And the wire is wound around the cross. One channel, the other channel. So I've twisted, and then I've turned them around the coil to come out again. That is compensation for crosstalk. So when I wind the left channel in the right channel and the right channel in the left channel, anti-phase,
Yes.
I crosstalk, cancelling, and therefore the channel separation is much higher. Channel separation measured by the absolute sound is 40 dB. And normally a cartridge reaches 28 to 30 dB.
So what is the cross made out of?
Very high mu metal iron. You can use nylon, but then the output is much less. So I take a little bit disadvantage of the non-linearity of the mu metal, but the output is very pleasant and healthy. This cartridge produces 0.95 millivolt at 5.6 centimeters per second, and normally it's 0.25, 0.3. The higher the output, the lower relatively the noise floor. So your area of dynamics is enlarged by a higher output, and the modulation curve is steeper. So mechanical input, electrical output. The higher the output per unit of movement, the higher the dynamics. This cartridge is relative high dynamic cartridge. The one with the highest dynamics is the Colibri Master Signature. There's an extremely steep curve. Many manufacturers don't care about the modulation curve. They are happy when there's some output. But I thought the steeper, the more realistic. So therefore my efforts to improve the modulation curve, mechanical input, electrical output. I'll take another. I have to heat up a little bit the coil to harden the adhesive. And touching the front end, heat is transferred. It's drying up now. Ready. Bend the leak out wires down. And add the dampers. Let me see. I have here a tube with dampers, colorings, when I'm lucky also cantilever with stylus, as I see. So this is little stuff. Looks good, looks easy, but you can hardly get. Open. So. Move the damper around the suspension wire. First the center damper. That's it. it forwards. That's it. Two other.
Which piece is this? Is this the rubber that you just put on?
I have a 3-piece damper.
3-piece damper.
This was number 1.
Yes.
What I have in my tweeze is number 2. And the number 3 is laying down. 2 and 3, the 2 rings are equal. It's very different in property to number 1, the white one.
Is this the same combination like on your different cartridges? Like, you know, the...
Each cartridge has its own combination.
The 3 dampening rubbers you described the other day, you know.
Each cartridge has its own combination of damping rings. I have about 10 different types at home. And for this cartridge I take this combination. What makes the sound for a bigger part?
What is the life of this material, you think, before it starts to lose its elastic properties?
You talked about the other day the store the rubber at minus 80 or something. He's asking how long, now that you take it out in the air, how long is this?
It has been a week out of, but it's normally at minus 18 Celsius in my deep freezer. And I take about 20 out, and after 2 weeks, 20, or in a week even 20 are finished, I take another 20. So this is conditioned from 1975. At that time, I saw a CD coming. Philips did want to buy my stylus patent. They thought if they buy my stylus patent, and they offered me 25,000 gulden, that I could have kept quiet, and they took away another potential, say between quotes, enemy for CD. But I refused. So it did cost me 25,000, but I had the right to continue. And I'm still happy I do, because my stylus, at that time ready, is sold in about 1.5 million samples. So 1.5 million cartridges have used my stylus shape. And the stylus shape was the beginning of my cartridge business.
So the other part of his question was, now we put this in the air, how long will the damper last?
Oh, that will last very long. As long as you don't smoke, the air is clean, what means your wife should not fry the potatoes in olive oil or any oil and let it just evaporate in the kitchen. Preferably you prepare your beef outside. So as long as the air is without oil, the rubber will stay. Because this rubber ages only by oil and by intense ultraviolet light. But you don't play outside in the sun, because then your rackets hang dripping over the platter. So that's not the way how you should do. So oil is the biggest enemy for a damper. There are cleaning liquids containing oil. And those cleaning liquids migrate over the stylus, over the coil, in the oil. Famous one is Audio Technica, I think 406 or 407, a blue liquid. Never use. If you want to clean the stylus, use vodka. So the cup on the bottle, fill it with vodka, take a very little pencil, dip in the vodka and move from the rear to the front of the cantilever. And that's the way how you clean. And as a reward, you can drink the rest of the cup and have a good day. So the coil is ready now.
So people have this new material that they like. They say you just push it against the stylus to clean it. What do you think of that?
If it's this sticky and it's clean.
They have that, I don't know, looks like silicone or something, I think. Say you push it on.
I would strongly recommend no mechanical contact, because you have no control over your hands. And some are controlled, others are not controlled, and you may break something you don't want to break. The best thing is to have liquid cleaning. Last, I'm not promoting it, but I have great respect for Last. So that's a good option, but I think pure vodka is the best. Don't take beer, don't take cognac, because cognac contains caramel to give it a sweet, nice taste, and it is a residue on the stylus. But vodka is very pure.
And then you can drink it.
If you like. Good, there are still 4 rings and the cantilever. I put the cantilever a little bit aside. first fix the colorings. Red one. That's it. Move them. I have to use tweezers. So blue ring at the blue wire, red ring at the red wire. You can see. So we have now a continuation of connection between the pin with the color to the blue wire at the soldering point and the rest. Outlining is okay. Now I take a little drill and secure the tube. There's no metal. Clean it and fix the rear pull.
What did you just do with the drill? I couldn't see that too well. But what did you put the drill through?
I put the drill through the opening where I fit the coil.
Okay.
And to avoid any obstruction, I first drill at 1.05 millimeter, so the brass tube with 1.0 millimeter will move in smoothly. I think you have serious plans to produce cartridges yourself. Do I? It is an interesting hobby, but the discussions with customers are not always so nice because they always know better. This is what I'm now doing most essential, that is outlining the coil, precisely 45-45. That's a matter of training. It's a part of a degree. Now squeeze one time and I pressure with 23 gram. Tighten the little one M1 by 1 screw. Control again, it's okay. Now I'm a little bit in trouble because the solder does not show up at 2 points on the inside and I still have to connect the wire. And that's complicated because when it's a flat surface I have to bend the wire and move in the solder. When there was a drip of solder I could move straight in. And straight in is easy connection, but moving the wire on a 90 degree and pushing in is very complicated. That's because of the very coarse shape of the tip.
It's like a 16 gauge wire tip.
Oh, this is a AWG 12 tip.
Very good.
And I need AWG 28 or AWG 30 or higher. I'll still try again to get some solder on the spot.
I knew I should have brought my iron.
Yeah. I must be careful now because the coil wires are there, and when I break one then I have to start again. So when I cannot make the connection, it's only the soldering device and nothing else. 2 are easy, so the 2 minus, but the 2 plus are complicated. I'll give it a try. If it doesn't work, then I have to apologize because that's out of control. You must be very easy in holding your soldering device in the left and the right hand. So I solder mostly as easy with left as right hand.
How did you set the tension of the suspension wire?
By pressing with 23 gram. How do you know I use 23 gram? That's a matter of experience. If I squeeze too much, I squeeze the rubber, flexibility is less, frequency ranges drop down at high end. When I let the tool loose, then there will be a lift in the high end, 3, 4, 5, 6 dB at 20K, and I can track 200 micron. Now, the art is to press it, and that's with 23 gram, with these rubbers, to have a flat frequency response, to have the lowest channel, the lowest crosstalk, and have still the flexibility that tracks 70 micron. So when I check the cartridge without further measurements and it tracks 70 micron, with these rubbers, I know it has a flat frequency response and a very high channel separation. That's the story around it. I'll give it a try. If it doesn't work, then I have to stop here. I can mount 2 of the 4, but not all 4. Now here I'm lucky. So I have a little bit of solder on the inside. Each cartridge has its own story, it's never the same. It worked. We're lucky. The next step is to connect the 4 wires in the drip of solder and to de-insulate also. So first straighten the wires and find out which is the plus and the minus. This is the plus wire, should go down. Remove the other 2. This is the minus. First check the minus, connect the minus. So this is broken now. Anyone who likes to have a little piece? I put it here on the table for... So. There's a simple way of de-insulating. I squeeze the wire. You can do with tweezers. Done. So now I move this end in the solder. Done. So one of the 4 is now connected. We take the plus wire. The plus wire is always difficult to connect. So I take them a little bit longer in case something goes wrong. Check again, it's the plus wire, because there must be a red identification. Squeeze. Done. I must have a little tweezer here, a special one for this purpose. But I don't see. Ah, here, yeah. This is an extremely thin one, so I can manipulate a little bit better. This is a difficult one. You can only do one time. Clean the soldering device, tip. Otherwise, oxidations building an extra thermal barrier. Done. So one channel is now connected. Do the other channel. First the upper wire. Separate the two, so you know what's plus or minus again. This is the plus, goes down. Always be careful because one uncontrolled movement and you can start the whole operation again. You see, coil mounting takes more time than putting the magnet circuit together. You must take the time for this, so when the family is telling, dinner's ready, come now, then you have a problem. I have to do this with my left hand, and my left hand is a little bit less stable than my right hand. Because I always carry my luggage on the left hand. Just a little bit, yes. So this is wire number 3. Done. Do these things fast. If you're uncertain, circling around, all is lost. Now the most difficult one, remove the wire a little bit backwards, and the last one. Do we have an ohm meter here to check the coils? No? Ah. Because the happy moment is there when the ohm meter says beep. Take the wire a little bit longer. Cut it in length. Put it here also. That's for collectors. Take the wire and squeeze the end. So when I come home on Tuesday morning at 7 o'clock, I can't do anything till Thursday. You may laugh, but sometimes customers think that you have unlimited time, and day and night you are ready for their demand. I take the special tweezer, first position the wire in the tweezer, and give it a try. No. It's even and sharp, but I'll try. Done. So we managed. Now correct the position of the wires.
So this wire is very low resistance. Is the ohm meter
It's
too much current to burn out the coil?
It's 13 ohm, 13.2 ohm.
13.2, okay.
So my advice is start loading 20 ohm. Minimum 600 ohm, maximum. If you like to hear dull music, load with 20 ohm. If it should be really big band orchestra, load with all the trumpets audible, 600 ohm, but the best is around 400, 475, 500 ohm.
So it's high enough ohm that the ohm meter is not going to burn out
That
the
is
coil.
sound-wise, not technically correct, but sound-wise is the best solution.
I just always worry you would burn out the coil, you know.
No, coil can handle about 1 milliamp. So an ohm meter with high current is a disaster. I had once to travel to Taiwan because my importer claimed that all coils he measured were broken.
That was my question.
Now then, at the beginning of my answer, And he said it was always my mistake, I did not measure, and I was a fool, and I didn't know what I was doing. So I went there with several cartridges, and I took my own ohm meter, and I measured them, and they were precisely 13 ohm, 30.2 ohm, 30.3 ohm. I said, now you measure. And he didn't measure anything. I said, who is here guilty? Your technician with a high current ohm meter, or me with a low current ohm meter? A low current still magnetizes the coil, but the external field is so strong that it overrides the optional magnetization you reduce in the hysteresis curve immediately to 0 when you add the front pole. So don't be too afraid for magnetization. But the only problem is if you have a magnetizer or a demagnetizer, it changes the wise complex structure of the armature such that instead of having a very fine step function to build up a sine wave, you get some rough steps. And the result will be sonic distortion. You cannot measure, but you hear. So never demagnetize an MC cartridge. Leave it as it is. That's the best way. Now comes something else complicated. I still have the cantilever here. You may see, or you may not see, I have a little black bar in the tweezer.
Oh my God.
Now I put that in front of. This is boron. Beryllium oxide is extremely poisonous. It's about 15 times more poisonous than red poison. So I don't want to touch any beryllium, but boron is extremely stable. This boron wire was made by a company to be used in the constellation, the Lockheed constellation, as a woven mat in an epoxy structure to give strength, because at that time carbon fiber was not available. So this was the first step in artificial material. As you know, the boron reinforced mats for the constellation stopped because the production of the constellation stopped. So I bought 6 kilometers of boron. What's high value at the moment, because 1 meter of boron costs at the moment around €600. 1 meter, and I have 6,000 meters at home. But instead of waiting till the car delivery brings me the second Tesla, I just continue to work and have no Tesla. That's my feeling. This is what I'm now doing also, a little bit based on real training, to position the stylus precisely in the correct position. St. William is reasonably good in doing these things. You need a white background to project the position of the stylus. It's about okay. The last, this is the other trick. The boron cantilever rotates in the tube of the armature, so I add always a little bit of adhesive at the top end. Yes, it's hardly anything, but it just avoids the rotating of the cantilever. Yes. Practically good. You must have really sharp eyes. Eyes are essential here, so don't overexpose and never watch TV. In the hotel here, there's a TV screen behind the mirror. That's on in the bathroom. So when you sit on the toilet and rotate 90 degrees, you can see the Simpsons. But even that challenge I haven't taken. So, stylus fixed. Add a very little bit of adhesive. For that reason I use the solder again, what is uncommon. But
when you do this at home, do you use higher magnification to be sure that that stylus is rotated correctly?
In the beginning,
just like this today.
In the beginning I did, now I don't. I know what I'm doing. Now we have to fix the front pole. The magnet is extremely strong, so when I just do this with my fingers, the front pole will flip. This is how the front pole looks like. Will flip out of my fingers and break immediately the brittle bone cantilever. So you have to hold the front pole tight. For that reason I have this cutter, only for this purpose. A while ago this cutter was somewhere, but not in my working place. I was lost. So I have the cutter. Now it's tricky. Oh yes, I have to clean first some extra adhesive at the front of the magnet. Otherwise I don't have a parallel mounting.
So that piece is ferrous.
Yes, sir. If it was copper, there shouldn't be any magnetic flux. The big advantage of a microscope at home is that you can repair watches. If you have children, you can repair anything they damage. You can turn the 2 pins of a fountain pen back again. Fix a diamond in a semi-gold ring, or fix a semi-gold diamond in a golden ring, or inverse situation, fix a semi-gold a semi-diamond in a semi-gold ring. That's a cheapie. You can buy these things in Las Vegas. So this is, when you hear click, it fits. This is the moment. This is a little bit... Yes. It's done. Adjust the front pole. From some parts, up to now, it takes maybe an hour, and you can make music. And with the part single, there's nothing. I check the movement of the cantilever in the front pole, that's okay. I check the movement of the damping rubber, that's okay. One of the secrets of a damping rubber is really it's a fast restoring rubber. So if it's a lazy one, the cantilever has no control, it starts to move. But if the rubber follows the armature, always contact, then you have a very well controlled movement. That's one of the good things of a good rubber. That's very exclusive at the moment because these rubbers are not made anymore. Put a sticker at front as proof that I have done something. You can put adhesive on the wood or adhesive on the sticker. I always put on the sticker. Any questions so far? The only question may be, where can I buy your components so I can start myself?
Well, a long time ago you mentioned if somebody didn't like their cartridge, was too bright or too whatever, that you would
Harry Pearson
send
said
it back
this.
to you and you would adjust it. So when you adjust, what changes on the cartridge to make people happy, because like you said, their system is not perfect.
There are audio files, all audio files have straight frequency response in the ears, up to 20K. There's no exception. Everyone is exactly 20K. But some are more 20K and others are less 20K. By pressing the rubber, I can fine-tune the cartridge. So a loose rubber, so not squeezed, gives automatically a 6 dB up. And no channel separation. And when I tighten too much, it rolls down, so you can compensate an aggressive phono stage by a dull cartridge. But that's not my aim.
So then you have to change those 3 little parts? That every
I can
cartridge
change,
when they
yeah,
send it back.
I can change the 3 parts, but for the Grimson I've selected these 3 rubbers as the ideal combination with the cross in this magnetic structure. When I make a frog, I use other rubbers. When I make an MC1, I use other rubbers. So I have a big selection of rubbers, and the combination of the rubbers is same as cooking some special Indian specific food with more curry of this and less curry of this, more curry of Madras and less curry of Pune. Or the other curry, say chicken curry, is done more from Pune and less from Madras. No, that's the way how you do it in cooking, and this is the way how we do with cartridges, based on listening and experience. And I'm not saying my ears are flat to 20K, but I'm a very well trained ears, and I play each cartridge for about 4 or 5 records, and then I know the sound, the quality. And when someone wants to have a cartridge for big band, Harry James, then I make another one. And if it's for a trio or quartet, I'm talking about music, nothing else, trio of the quartet, then I use other rubbers to have a correct balance for the trio of the quartet. Someone likes more Mozart, someone likes, for instance, Decca recordings, SXL recordings. Then I make one specifically for SXL recordings because I know the sound of Decca. If you have an SME 5, it's a minor difference to, for instance, an EPA 100. So each tone arm has also its own characteristics. By changing the rubbers, changing the diameter of the suspension wire, changing the gap, you can fine-tune a cartridge. So by differences in material, you can have differences in sound.
So it's important for them to tell you what tone arm it's going to go in.
Exactly. And not that the importer says, I need 5 Grimsons. But he doesn't tell me what arm or what's the taste of the owner. He pays serious money, and I think he has the right to get the cartridge that fits best his system.
I don't know your models, so you said I think there were 12 models maybe. Are they all equally hard to build?
Some are even more difficult to build. Like
where does this one fall? Is this
this is one to the top. The Colibri is the most difficult one to build, but I have several models of Colibri. So say 4 or 5 models. So this is number 6 in the order of difficulty. And I've done rather fast, despite the handicap of the soldering, because that was not good. So the pins were heated a little bit too much, and the solder didn't flow well, but all is connected, and it will play today.
What magnification do you need to have to inspect the styles?
5 is enough.
500?
5.
5?
5, yes. No, I use 5 to 10. I just tune it home. When the cartridge comes for repair, then I'll check first the wear of the stylus. So when is the top of the stylus and the outer part. So here's the toner. The outer part has worn more than the inner part. I know that the anti-skating adjustment had been too high. Many cartridges have always a too high anti-skating. So always the bass, the celli, in the classical orchestra are worn more than the violins. So have hardly any anti-skating. My stylus have hardly any friction in the groove. So no wear, so using very limited anti-skating. Therefore say 0.3 gram, 0.4 gram, that's sufficient. Yes, sir?
When you rebuild a cartridge, you replace the inner wiring also?
When the coil is okay, I leave it to save cost. But when the coil is damaged, and mostly there's metal fatigue between the coil and the lead out wire, then you see the impedance going up, and then I change the coil to avoid warranty claims later, because it's already a worn coil. So 30, 40-year-old MC cartridges, I have to replace the coil to be sure that the metal fatigue between the fixed armature and the moving wire is not too damaged at the point where the wire leaves the coil. Therefore I made this special turn to save lifetime for the lead out wire. Is one of the reasons why I make this turn. It's not crosstalk cancellation, but also saving metal fatigue problems. Companies producing cartridges always put adhesive at the point where the wire leaves the coil. Specifically there, the wire will break. It's a too rough change from grip to free. So if you would like to add adhesive, have a very flexible adhesive, so it bends a little bit together with the movements. 20 kilohertz is some movements a second. And if you have a wire hanging behind the house where your wife is hanging the laundry, and you need a little bit of wire, it's 20 times breaking, and a little bit of the laundry wire of your wife is available for you, and she has less to hang the napkins. But that's 20 times. A thinner wire can bend more, but there's always a limitation between bending and lifetime and breaking. I'm working at the moment with a wire made from carbon nanotube to make a cartridge coil made of carbon nanotube, graphene, and that's built forever. It will never break anymore. But I'm still busy with the insulation, because insulated carbon nanotube is one, but to de-insulate, that's the problem. I think I have to clean a little bit because the next group may show up. Any further questions? No one interested in this cartridge? No, you had a wonderful opportunity. Thanks for coming here anyhow and asking serious questions.
So which Colibri is that?
This is the Grimson, it's not the Colibri.
It's what?
This is Grimson, not the Colibri.
How does that rate according to the Colibri? Is it better or?
The channel separation of the Colibri is higher, the dynamic range is higher, tracking is the same, output is a little bit less, sonic impression is stronger, but it costs also more. And Grimson is a good middle-of-the-road cartridge with acceptable price and a good performance.